Okay, so we're going to now start with covalent compounds. We've been spending a few days on ionic compounds. It's time to look at the other group, covalent compounds. So let's start with some of the contrasts between the two of them. First of all, covalent compounds are made up of two nonmetals. The ionic ones, every time I use brackets on this slide, it's going to be referring to ionic compounds. The ionic ones are a metal and nonmetal, but the covalent compounds use just two nonmetals. They tend to have low melting points and low boiling points, and because of this, they're often gases, liquids, or low melting point solids at room temperature, things like wax. So they tend to be soft and are usually more flexible. Remember, the metals the ionic compounds tended to be hard and brittle. Many of them, well, some of them have odors. Ionic compounds don't have odors, but sometimes we mess that up because we think, well, sometimes we smell something that's an ionic compound, it's got an odor. Well, it's an impurity. The ionic compounds don't have an odor because they have a high melting point, high boiling point, and you've got to have a gas in order to smell it. Next, some covalent compounds will dissolve in water. Now, some do, some don't. If they do dissolve, however, they will never conduct, so they're not electrolytes. So remember sugar water? Sugar got to dissolve, but it would not conduct. Now, we talked about the octet rule, saying that atoms will gain, lose, or share in order to form, or in order to have 8 valence electrons. Well, covalent compounds, they do this by the sharing. The metals and nonmetals and ionic compounds, they gain and lose, whereas covalent compounds, they are always sharing. So, the last point on this slide is these actually form individual molecules. So, whenever we talk about their symbol, and we see the specific number of atoms, that's exactly how many atoms form a group, where ionic compounds, because they're oppositely charged ions, it's a fairly large structure that has oppositely charged ions attracting one another. So here we go on to, there are 7 different elements that when we find them as elements, always come in pairs. So they get the term diatomic, di meaning 2. So when we name them, we simply say what the element name is, followed by its state. So it's either going to be something solid, liquid, or gas. And the 7 elements that always come in pairs are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, the neat thing about them is this. When we look at these last 6 of them here, these guys, if you look at your periodic table and you start with nitrogen, go across and then down, you find nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They form the shape of a 7. So the other one that's odd out is the hydrogen. So that's one way that you can maybe keep those guys straight. Now, when we draw these molecules, shared electrons are drawn in ovals between the elements, not the arrows like we used before. So we're going to do a couple quick examples of some of these diatomic molecules. So we're going to start with example 1, hydrogen. So we look on the periodic table just like we would for ionic compounds, and we're going to draw the symbol for hydrogen, which is H, and we put a dot. Now, because we've only have 2 atoms, we put the other hydrogen, and we put a dot. Now, I'm going to accentuate this by changing colors. I'm not expecting you guys to change colors, but you can if you wish to. We draw an oval around the pair of electrons, and now each atom can count the 2 electrons in the oval. Hydrogen is weird because it likes to have only 2. The octet rule says 8. Hydrogen is the exception. It likes to have 2. So let's take one that follows the octet rule, nitrogen. So for nitrogen, nitrogen is in group 5 on the periodic table, so N, and 1, 2, 3, 4, and those arrows allowed us to kind of put the paired electron wherever we want. I'm going to put the paired electron on the left, so I have a pair of electrons on the left, unpaired on the top, bottom, and right. I'm going to draw my other nitrogen here, and put 1, 2, 3, 4, and like I said before, I can choose where I put that 5th electron, so I have a pair where I want, and it's usually better to have the pairs away from the other atoms because that's not where the bond is going to be. Now, Switching colors again. So I'm going to draw an oval around this pair. And now if I look at the nitrogen on the left, what I've got is 2 on the left-hand side, 1 on the top, 1 on the bottom, that's 4. But I have, within that oval, I've got the 1 there, I got the 1 there. So there's 2 more in the oval, and the 1 on the left gets to count it, so that's a total of 6. So it's not quite happy yet. But we look at the one on the right, and it's also got 6, 2 in the oval and 4 more not. So we can continue the sharing process. I'm going to share the 2 on the top. And now we're a little closer because now they're sharing 2 in the top oval, 2 in the middle, in the bottom oval, that's 4, plus on the left-hand side, 5, 6, and the bottom is 7. But the right-hand one is in exactly the same situation. So we can draw one more oval. And now we can say that sharing, they've got 6 shared electrons, and each one has 2 that they're not sharing. So when we're describing these, the top one for hydrogen is a single covalent bond. Whereas the bottom one is a triple covalent bond. Because there's 3 pairs of electrons being shared in nitrogen, but only 1 pair of electrons being shared in single. Now, this can be expanded to form compounds between 2 different elements, and we're going to do some examples of that in class. So this should give you a starting point. Thanks for watching.